I'm about to attempt to work through a massive amount of material in a very short amount of time. This is actually a vocab lesson, not a math lesson. So just think through everything that I'm saying and pay special attention to the vocab, maybe take notes on it, and don't focus as much on the math. I'm going to try to make the math component of it pretty easy. Okay, so when you are working with a sequence that's just a number pattern, it's just a series of numbers, and there are three different ways that you can write it that are useful in different ways and at different times. One is you can just declare the sequence. That means you just write every term in the number pattern from the beginning to the end. Another is that you can use the explicit definition, and I'll tell you what that means. And you can also write a recursive definition. But this all makes a lot more sense when you see an example of it, so I'm going to roll an example of it right now. If you simply declare a sequence, then all you have to do, we use curly braces for this most often, and you just write every term in the sequence. So the one that I'm working with in particular starts at 7, and then goes to 9, and then goes to 11, and then goes to 13, and that's the end of that sequence. So it's 4 numbers long, and think it shouldn't be too hard for you. You see the pattern? Pause it if you don't. Pattern here is plus 2. So 7 plus 2 is 9, plus 2 is 11, plus 2 is 13. We can define this explicitly, and we'll go into what that looks like a second ago, but the recursive definition is actually much, much easier. In order to understand it, though, you need to see one more notation piece of this. The way that you name this sequence, so we've declared it, but in order to name it, kind of like in computer science, I have to say some variable equals. You use these brackets again to show that it's a sequence. A is the most common word that you'll hear used to define a sequence. And you'll use A sub K. The sub comes into play just a little bit, you'll see. And then you've got to tell where it starts and where it ends. So K, it starts with K equals 0. And after this term, there are 1, 2, 3 extras, so it goes up to 3 others. So it's like your starting point plus 3 more gives you 4 total pieces. That's a little bit confusing, but it's also really comparable to the way that you use arrays in computer science. Most indexing in computer science means that this first term would be considered A sub 0. The second term would be considered A sub 1. The third term would be considered A sub 2. And the last term would be considered A sub 3. So these are just the names of them. A sub 0, the first one, and then all the rest of them. You may notice that it can be a little bit confusing that the number of the term is 1 less than it's the third term, but it's A sub 2. But that's because you always start with your 0th term. Your starting point isn't even 1. You haven't done anything yet. So to define something recursively is really, really easy. You just write the first term and then say the rule. So if I want to define this pattern recursively, that means it bends in on itself. So I would say that A sub 0 is equal to 7. So I'm giving my very first term. And then every other term, so A sub any other number, A sub K, is going to be equal to A sub K minus 1. That means the last one. So if I'm trying to find A sub 2, I'll use A sub 1 to get there. And whatever the last term was, I'll just add 2 to it. So this basically means take the last number, the previous term, and add 2 to it to get the term you're looking for. So if I'm looking for A sub 20, well, that means I'm going to have to find A sub 19, which means I'm going to have to find A sub 18. I'm going to have to keep going back in time all the way to A sub 0. So this is really useful in terms of being easy to present, but this can be frustrating if you're trying to find something like A sub 20. The 20th term in a sequence, or A sub 20 would actually be the 21st term in the sequence, but finding something that's that far down the pattern would involve 20 individual math steps, and that can be pretty tricky. Now, if you're thinking about this sequence that just says plus 2 every time can also be defined to where you just tell somebody exactly how to find which term they're looking for without having to go through all the steps of finding every intermediate term. So, an explicit definition lets you get right to the heart of the matter and get right to the meat of whichever term you're looking for. So, an explicitly defined function, you would just say, take A sub K, and whatever K is, Well, we know it's just going to be 7 plus 2 times whichever term you're looking for. And we can double check this by finding a sub 3. So real quickly, a sub 3 would be 7 plus 2 times 3. You're plugging in 3 for k. 2 times 3 is 6, so 7 plus 6. 7 plus 6 is equal to 13, and that is in fact what a sub 3 is. So we've proven that this works, or we've at least tested it in one case. So now, finding a sub 20 would be a lot easier. We would just take a sub 20. I'm writing really small because I'm about to do something else underneath here. But a sub 20 would be 7 plus 2 times 20, which is 7 plus 40, which is 47. And I got there without having to do 19 intermediary steps between the first one and the last one. This is a long video, so I'm going to pause it. I'm going to pick it up in a second.